are going to demonstrate the operational capabilities of the Express Rack Demonstration Unit. The demonstration unit currently has the capability to activate 6 mid-deck locker type payloads up in the top portion of the rack, and that includes the capability for a double mid-deck locker type payload is located here. We also have the capability for 3 SIR drawers down here in the bottom portion of the rack. That also is a capability for an 8-panel unit drawer. And we believe in our flight unit we will be able to incorporate 1 more 4-panel unit drawer and possibly a 5th drawer.
My name is Rick Size, and I'm going to be talking about the command and control and statusing from the ground station, or as it's referred to, the USOC. This is the typical monitor of the Express Rack. We did this using lab windows. On the left side of the screen you'll see temperatures. These temperatures are located throughout the Express Rack so that we can monitor if anything is overheating or any payloads causing any type of thermal disturbance. At the bottom here, this is monitoring the power consumption of the rack so that we can also monitor how much power is being utilized by the Express Rack. On the Express Rack, we interchange payloads without powering down the computers, so we can't afford to go through a software changeout of the controller on the Express Rack itself. So what we do is we create tables. Here I am loading SAMs into the Express Rack. That will tell the controller what type of data interface and what frequency it wants to monitor. I will go ahead and load the other experiments into the Express Rack now.
Now I'm going to move right into the operation of the rack. The first payload I'm going to activate through a local front face control, and that's the SAMs unit. As you can see, the astronaut has the capability of activating power directly at the front face. The SAMs unit is powering up. SAMs is provided to us by Lewis Research Center. It stands for Space Acceleration Measurement System, and it will monitor the accelerations within the rack. The SAMs unit also has incorporated in it the capability to store its data on an optical drive.
Our next experiment that we're showing is the test. I will go ahead and power it on from the USOC. Now what we want to show on the test is the remote command and control capability from the users. The user can link into the USOC through a modem or other network capability and control his experiment. What I'm going to do now is I'm going to go ahead and start up the test experiment. Okay, now that that's started up, and you'll be able to see on the test experiment the display come up, as John presses the buttons, you'll see that's being telemetred down to the ground station and relayed off to the user site. So we have complete command and control from the ground or from the user site.
And the next payload we're going to talk about is 2 double mid-deck locker type payloads. Plain mid-deck locker payloads such as this one and this one here. This one is provided to us by Langley Research Center. It's a MACE, which is Mid-Deck Actively Controlled Experiment. It's designed to go up in the mid-deck. Once it's on orbit, you open the door, you connect power and data, and you activate the payload. The next type of mid-deck payload we have is heat pipe performance. It was provided to us by the people at JSC. It flies up in the Express Rack strictly as a storage item. Then once it's on orbit, you bring the items out into the aisleway and operate them there. And the final unit we have is the S-Test, which is single thermal enclosure system, and Rick can activate that from the ground station also. The S-test, like the test, is used to grow protein crystal growths in microgravity. Now the next type of operation we want to show is activation of payloads from the laptop computer. And I'm going to activate those from the laptop that's located over here. This particular laptop was provided to us by Yuri Godiak at NASA Level 1. It's a prototype of a unit that would be used in space station. It has a 120 megabyte removable hard disk, and it also has a full active matrix display. You'll also notice that I have the same features on the laptop as Rick Size has on the ground station simulator. And I'm going to move over here and activate the JSC temp from this location. The JSC Life Sciences temperature monitor was provided to us by the people at JSC that developed the Sir George Bill Davis. And it provides a simulation of a temperature monitor. The last payload we're going to activate is the fluid science experiment. It's located in this 8-pound-a-unit drawer. It's provided to us by the European Space Agency, and it's used to study the Marangoni effects in microgravity. And I'm going to activate it from the laptop computer, and then we'll be able to see the video downlink on the monitor. You see, this is live video coming out of the fluid science experiment, downlinking through our video. A needle is being pushed down into a cylinder of alcohol and water for a demo. It'll go to a certain point, pull back, and release a droplet of silicone oil. The last thing we want to demonstrate is the capability to change out a payload on orbit, and we're going to change out the JSC Life Sciences temperature monitor for the JSC Life Sciences echocardiograph. And you'll see how easy it is to remove the drawers from the rack. And to install a new drawer into the rack. And once the drawer is installed, then it's ready to be powered up again.